Welcome to ScienceCover.com. In this session, we look at distance-time graphs. The aims of the session are to learn to read a distance-time graph, to calculate the gradient from a distance-time graph, and to know how to use a tangent to calculate the gradient from a curve. Before we begin, pause the video and attempt to do now task. Let's check the answers. For question 1, we should have got 5 meters per second. For question 2, 6 meters per second. Question 3, 30 meters. Question 4, 20 meters. Question 5, 0.3 seconds. And question 6, 500 seconds. Let's now look at how to read a distance-time graph. Speed often changes over a journey. Rather than show large tables of data with speeds at different points, it's easier to view this data on a graph. On most distance-time graphs, time is usually plotted on the x-axis, with distance on the y-axis. A diagonal rising line means that an object is moving forward. A straight line tells us that the speed is constant. A horizontal line tells us no distance is being added, so the object must be stationary. A diagonal falling line means that the object is moving back to its start location, so it's in the reverse direction. Curved lines mean that the speed of the object is changing. It's either accelerating or decelerating. A line curving towards the vertical shows an acceleration. That means speed is increasing. Whereas a line curving towards the horizontal shows a deceleration, so speed is decreasing. This distance-time graph shows the journey of a car. We can see that between 0 and 10 seconds, the car travels with a constant speed. We know this as we have a straight line, and that the line is increasing in height. Between 10 and 20 seconds, the car is stationary. We know this as we have a horizontal line. Between 20 and 27 seconds, the car accelerates. We know this as we can see a curved line. Between 27 and 35 seconds, the car travels at a constant speed. We know this as again we have a straight line increasing in height. And between 35 and 45 seconds, the car is stationary. We know this as again we have a horizontal line. Pause the video now and attempt task 1. Let's check the answers to task 1. Graph A is showing an object at constant speed. Graph B is showing a stationary object. Graph C is showing a constant speed in the reverse direction. Graph D is showing an object accelerating. Graph E is showing a constant speed, which is faster than A, and we know this as the gradient of the line is steeper. Graph F is showing acceleration in the reverse direction. Graph G is showing an object decelerating. And graph H is showing a deceleration in the reverse direction. In question 2, we're asked which part of this graph represents a constant speed. That could be either A or C. Where is the graph stationary? This is going to be at B or E. Which part of the graph represents a deceleration? This is going to be D. Now, which part of the graph is her speed fastest? That will be C, so at this point the gradient of the line is steepest. You're then asked to write a short story to describe the journey. Any account will be accurate as long as it describes a constant acceleration for 10 seconds, a period where the object is stationary for 10 seconds, a constant speed for 5 or 6 seconds, a deceleration, followed by a stationary period for 10 to 11 seconds. Let's have a look at how to calculate the gradient of a graph. A gradient is calculated by dividing the change in the y-axis by the change in the x-axis. This means taking a distance and dividing it by a time. We know that a distance divided by a time is a speed. Therefore, the gradient is telling us what speed the object is travelling at. A steep line means we have a sharp gradient, and this represents a fast object. Whereas a shallow line gives us a low gradient, so this means we have a low speed. Let's look at an example of how we can work out the speed of an object from its gradient. Here we can see the line for object A. If we pick 2 points along this line, we can create a right-angled triangle. We can now measure the height of the triangle, which we can see is 60 meters. And we can measure the width of the triangle, which we see is 10 seconds. So to find the gradient, we need to find the change in the height divided by the change in the width. This is 60 divided by 10. 60 divided by 10 is 6. And since we've divided a distance in meters by a time in seconds, the units are meters per second. We can repeat this process for object B. We pick 2 points along the line and create a right-angled triangle. We then work out the height of the triangle, which we can see is 40 meters, and the length of the triangle we can see is 20 seconds. The gradient is the change in the height divided by the change in the length. This is 40 divided by 20. And this gives us 2, and the units are meters per second. Pause the video now and complete task 2. Let's check the answers to task 2. Which was the fastest object? It was the motorbike. During the testing, there were issues with the sports car. What issues did the company have with the sports car? Well, we can see from the graph that the sports car did not move. And we can tell this because the graph is showing a horizontal line, It's gaining no distance. Question 3 asks us to calculate the speed of the motorbike, the car and the tractor. To do this, a right-angle triangle has to be drawn on each line. We can then use this right-angle triangle to calculate the gradient of the line. So for the motorbike, this is shown in orange, and the gradient should have been around 5 meters per second. For the car, this is shown in green, and the gradient should have been around 2.5 meters per second. And for the tractor, this is shown in blue, and the gradient should have been around 0.5 meters per second. Now let's look at why we might want to draw a tangent to the graph. An accelerating object on a distance-time graph gives a curved line. So we cannot use this directly to calculate the gradient and speed. Instead, we must draw a tangent. A tangent is a straight line touching the graph at the point we are measuring. It has the same gradient as the curve. This graph shows the acceleration of a boy sprinting. If we want to work out the boy's speed 30 seconds into his run, we must draw a tangent to the line. This tangent will touch the line at the 30-second point. It should have an equal gradient or steepness to the graph line at this 30-second point. We can now work out the gradient of the tangent. To do this, pick 2 points along the tangent's line. And turn these 2 points into a right-angled triangle. We can now measure the height of the triangle, which in this case is 75 meters, and the width of the triangle, which is 30 seconds. The gradient is equal to the change in the height divided by the change in the width. So this is 75 divided by 30. And this gives us 2.5 meters per second. So at the 30-second point into his run, this boy was moving at 2.5 meters per second. Pause the video now and complete task 3. Let's check our answers. In this task, we're asked to calculate the speed of the vehicle at the 30-second point on the graph. So to do this, we have to draw a tangent touching the line at 30 seconds. We then work out the gradient of the tangent. Now if we do this, we can see that we get a value of 1 meter per second.